Build skills with experts anytime, anywhere. Get certified, get ahead. The world's largest selection of courses, affordable online courses and learning opportunities, top categories.
In this module, we will set up the Jupyter Notebook on the local machine. To run the Jupyter Notebook on your local machine, we can use our terminal or command prompt if you are on the Windows machine. In our working directory, let's create a folder named as Module 2. Let's navigate to this folder. So inside this folder, we can use the following command: Jupyter space Notebook. You can also specify the port number using the port flag. If you do not specify the port number, the notebook will try to use the default port number of 8888. To know more about the notebook server options, you can use the help flag. So as you can see, there are several options here. One common option, that is no browser option. You can use this option especially on systems that don't have any graphical user interface. So this will start the notebook server without opening a web browser. This is a very common scenario where you want to host the Jupyter Notebooks on cloud, so that you can run the notebook server without any browser and then use your own local machine to access the notebooks. Anyways, let's use the default Jupyter Notebook to launch the notebook server on your local machine. So here we have the Jupyter Notebook in our default web browser. Now you're all set to go. In the next clip, we will start exploring the Jupyter Notebooks and we'll learn some basics. In this module, we will set up the Jupyter Notebook on the local machine. To run the Jupyter Notebook on your local machine, we can use our terminal or command prompt if you are on the Windows machine. In our working directory, let's create a folder named as Module 2. Let's navigate to this folder. So inside this folder, we can use the following command: Jupyter space Notebook. You can also specify the port number using the port flag. If you do not specify the port number, the notebook will try to use the default port number of 8888. To know more about the notebook server options, you can use the help flag. So as you can see, there are several options here. One common option, that is no browser option. You can use this option especially on systems that don't have any graphical user interface. So this will start the notebook server without opening a web browser. This is a very common scenario where you want to host the Jupyter Notebooks on cloud, so that you can run the notebook server without any browser and then use your own local machine to access the notebooks. Anyways, let's use the default Jupyter Notebook to launch the notebook server on your local machine. So here we have the Jupyter Notebook in our default web browser. Now you're all set to go. In the next clip, we will start exploring the Jupyter Notebooks and we'll learn some basics. In this module, you will learn about the basics of Jupyter Notebooks. So in order to create a new notebook, you can click on this new drop-down menu and select the Python kernel. If you have other kernels installed, then the other kernels will also be listed out here. Let's pick the Python 2 as of now. So here is the new notebook. Let's give it a name. To set the name, you can click on this untitled area. Now you can type the name of your notebook. Let's set it as my first notebook. Well, a Jupyter Notebook is made up of cells. By default, you will get one cell and you can create additional ones as well. These cells can contain different types of items. By default, whenever you write in these cells, they will be treated as code, which in our case is a Python code. If you would have selected different kernels such as R or any other language, then the text will be treated as code in that particular language. Now let's write the Hello World Python code here. Now to execute this cell, you can go to cell and click Run, or you can use the keyboard shortcut Ctrl+Enter. We will use this keyboard shortcut to execute the cell. And here you can see the output just below the cell. This is really great because now you can write your code and view the results side by side. Another thing you might have noticed about this square bracket after the letters IN. So if you see the square brackets, this means the cell contains some code. And each time you will execute the cell, the square bracket will show the execution number of the code cells. Another important thing is that when you are using the Ctrl+Enter, then it will execute the cell and the focus will remain on that particular cell only. However, if you use another very helpful keyboard shortcut, that is Shift+Enter, then not only it will execute the cell, it will also create a cell just below it. Let's try that. So as you can see, a new cell is created. So let's use this new cell to enter some markdowns. You might be familiar with markdowns. Markdowns are used to create formatted text on web browsers. To convert the cell type to markdown, you can go to cell, go to cell type, and then select markdown. However, we will learn another keyboard shortcut for doing this. The keyboard shortcut is Escape+M, M for markdown. Keyboard shortcuts are very helpful, and once you are accustomed to these, you will find it really easy and fast. So here we have used the keyboard shortcut Escape+M to convert this cell to a markdown cell. Also, as soon as this cell is converted to a markdown cell, the square bracket from the left of the cell has been removed. Now let's see some basic markdowns that we will use throughout this course. So just like the h1 to h6 tags in HTML, you can use hash symbols. So single hash is similar to h1 tag. Let's write something using single hash. So here you can see the size is quite large and font weight is bold. Typically you want to use single hash for the main title of the notebook. If you want smaller fonts, then you can use more hashes. Let's add more hashes. If I add more hash symbols, the font size is decreased. So this is just like h1, h2 and h3 kind of tags. Now to execute the cell, again you can use the Ctrl+Enter or Shift+Enter if you want to create a new cell after execution. So now you're comfortable with code and markdown cells. Let's do some more hands-on. Here I have added some bunch of cells, and we will go through each of these cells to learn more about Jupyter Notebooks. So let's learn a very simple code. Just type 2 + 2 and you can get the output by executing this cell. Then we have created a variable x. Now let's print out the variable content in the next cell using the Python print command. And here we have the output 3. So you can think one notebook as your working environment, and any global variable that you create in any cell can be used anywhere in other cells. Moving on to the next cell, here we have created a Python function definition. Let's execute this cell. So the function is now created. Now we can call this function and pass some parameter value. And here we have the output. Now let's learn some more keyboard shortcuts. Suppose you have a long code block. Then for such scenarios, you may also want to add line numbers for your reference. So in order to get the line numbers, you can use the keyboard shortcut Escape+L. And here we have the line numbers. It can be very handy, especially if you encounter some error and error shows the issue related to a specific line number. If you want to know more keyboard shortcuts, you can go to Help and click Keyboard Shortcuts. And here you will find all keyboard shortcuts that you can use. I'll again recommend that you use some of the keyboard shortcuts because it will make your life easier. Moving on to another very useful tip, which I find really handy, and it is the simple exclamation mark. This will help you to run any shell commands in the notebook itself. Let's use it to check the version of the Python installed on your machine. Let's execute this shell. And voila, we can get the shell command output right in our notebook. Isn't it great? So now you're comfortable with the Jupyter Notebook and its environment. In the next clip, we'll talk about another very fascinating feature of Jupyter Notebooks, that are magic functions. But before moving to the next clip, let's save this notebook. Here you can notice the notebook gets auto-saved after some time interval. But if you want to explicitly save it, then you can go to File and then click on Save and Checkpoint. The keyboard shortcut is Command+S on Mac and Control+S on Windows machine. Now let's move to the magic function demo in the next clip. In this clip, we will talk about data science project template. You might be familiar with project templates if you are coming from any software development background. Well, if you look into a typical data science project, it has several components. So you can have raw data, processed data, you will have some notebooks, some models, few visualizations, some reports, it can have documentations and references as well. So as you can see, even for a small project, there can be so many pieces. And for a moderate scale and large scale data science projects, things can quickly go out of hand. Therefore, it is very important that we organize our data science project in a manner that other team members can also follow. So you can think a data science project template as structuring of different pieces or artifacts of your data science project in a consistent fashion. So what are the benefits of having a template? A project template will lead to a more consistent project structure, and it will standardize the way people in your team are expected to work. It also makes collaboration easy as different team members can work in their specified zones, and others will know where to look if they require any specific piece of information. And if there is any new team member joining your project team, then he or she can understand the project structure and dive in right away without going through the extensive documentation. Reusability is another very important aspect in a data science project. You should be able to produce similar set of results or analysis from the raw data in a reproducible manner. This will also ensure better code quality, and you will be more confident about your work and results. Following a structured approach will ensure the reusability and code quality right from the beginning. So the key takeaway here is that if you are following any standardized approach, your life will be easy. So the next and very obvious question is that what is an appropriate project structure or template in a data science world? Well, there is no definite answer to this question. Your team might already be having a project template and you can follow that. But whatever project template you pick, my advice is to use it from the word go. Even if you are doing for your individual projects, then also following a standardized template will help you in the long run. In this course, we will follow a project template that is specifically designed for data science projects, and it is Cookie Cutter Data Science Project Template from Driven Data. It is available on GitHub, so you can check out this link as well to know more. I personally found it as one of the most appropriate data science project templates so far. But you are free to follow any other project template if you wish. In the next clip, we will set up Cookie Cutter project template and then we will explore its components. In this clip, we will set up the Cookie Cutter Data Science project template. To set up any project using the Cookie Cutter template, you will first have to install it. So if you are using pip, then you can go to your terminal and type pip install cookie cutter. But if you have installed the Anaconda distribution, then you can also use the Conda install. So let's use it. Let's proceed. Once you have installed the package, you can use it to create a new project. So here we are in our working directory. Let's clear the screen first. Now we can type cookie cutter followed by the cookie cutter GitHub repo link. Press enter. This will clone the project structure from GitHub to your local machine. It will then ask you about some basic information about your project, such as the project name. So let's give it a name. And as we'll be working on the Titanic disaster dataset, let's give it a name Titanic. You can add the repo name as well if you want to link this to a GitHub. You can add the author name, some description. You can select the license type. You can also provide the S3 bucket details if you want to sync data between S3 and your local project. Let's skip it for now. You can also provide your AWS credentials. Then you can select your Python interpreter. As we'll be working with the Python 2, let's select the first option. So now you are done. Now let's do an ls to the current directory. So now we have a folder corresponding to the project name, that is Titanic. Let's get into this directory. Now let's see the structure of this folder using the tree command. Here I have set the level to be 3. As you can see, this template has several components. We will not be using all of the components, but it's good to know about different placeholders and how a typical data science project is structured. So from the top, you have a license file. Then you have a make file. These are the typical make files that are used to run different scripts. Then inside the data folder, we have different subfolders. External will contain the data from third-party sources. Interim will contain the intermediate data that has been transformed. Processed folder will contain the final data that will be used for modeling activities. And raw folder will contain the original data. And you don't want to modify the raw data in place. So this is an immutable thing. Then you have docs for the documentation. Models folder will contain different models or model summaries. Notebooks folder will contain all of the Jupyter notebooks. Then the references folder will contain manuals or any other material that you want to include in your project. Reports folder can contain the final analysis in different formats such as HTML or PDF or LaTeX. Figures subfolder can contain different graphics or figures that you may want to include in your reports. Requirements.txt file can be used to reproduce the analysis environment so that the others can install the packages that you have used to generate the results. src folder will contain the source code for your project. It also contains an init file so that it can be converted into a Python module. Then all of the scripts to download and generate the data can reside in the data subfolder. Features subfolder can contain scripts to convert the raw data into features that will be used for modeling. Model subfolder can contain scripts to train the model and use the model for prediction. Then you have the visualizations folder that can contain scripts to create visualizations that are part of your project. The cookie cutter template also contains files for setting up test environment and talks.ini file if you want to use talks for automated testing. Although in this course, we will not be using all portions of this template as we will be mostly concentrating on notebooks, but such a standardized approach can greatly help you in the long run. Another important aspect of a data science project is version control, especially if you are working in a collaborative fashion. So in the next clip, we will talk about the importance of versioning in data science projects. Versioning is a very important aspect for any kind of team or collaborative work. The same is applied to data science projects as well. Versioning system can provide a better collaboration among the team by providing a common repository on which different team members can work together without messing things up. You can also track your changes in a better fashion, and in case you have made some major errors, you can always go back to your previous commits. All the benefits we have discussed apply even if it is an individual project. Take my words, you will have a sense of relief if you are using some kind of versioning system right from the beginning. And I would highly recommend that you start using the versioning system for all of your data science projects. So which versioning system should you use for your data science project? Well, you can pick any one of your favorite. However, the most famous versioning system that is out there is Git. It is simple to use and is very powerful. And I think you should definitely spend some time learning Git. It will pay off in the long run. And if you want to share your work with your team members or publicly, then you can also take benefits of various service providers such as GitHub or Bitbucket. GitHub has become a very common choice for data scientists these days to showcase their work and to contribute to the open source projects. But I'll reiterate once again, whatever versioning system you pick, try to have it as a part of your project right from the inception phase. In the next clip, we will use Git to add versioning to our Titanic project. In this clip, we will add our project to a versioning system, that is Git. In this course, we will be using the Git versioning system, but you are free to use any versioning system of your choice. If you want to know more about Git, then Pluralsight has some great resources on Git. However, we will not be using advanced Git features in this course, so the commands used in this clip will be more than sufficient for the purpose of this course. So let's set up the Git on the Titanic project folder. Let's first make sure that we are on the Titanic project root folder. So we are in the Titanic project folder. Now, in order to initialize a Git repository, we can use the git init command. This will initialize an empty Git repository. Next, in order to add files to the Git versioning system, you can use the git add command. We have also specified dot. That means take all the files into this folder and add to the versioning system. Press enter. Now let's commit our changes using the git commit command. This will tell Git that we are done with our changes and now you can create a checkpoint. Also, you should always provide some commit message so that later on you can reference it, what changes you have done. And because this is an initial commit, we are adding a message initial commit using the -m flag. Press enter. Now the changes have been committed to our local Git repository. Now, in order to check the log, you can use the git log command. You can also specify another flag, one line, that will only give you the git commit message along with the commit ID. And here we can see our git commit message. So now our project has a versioning system in place and we are all set to work on this Titanic project in the upcoming modules.